express log base 7 of quantity x squared minus 1, quantity y to the fourth over 8z to the third, all raised to the fifth power as a sum of difference of logs. All right, so when you're encountered with these problems, you're going to use the three rules that we have about logs: product rule, quotient rule, and the power rule. The product rule basically states if you're adding two logs together with the same base, it's equal to a log with the same base, the product of the arguments. Those are basically the inside. So that's what rule 1 says. Rule 2 says that if you have a difference of two logs with the same base, it's equal to the log of that base of the quotients of the arguments, or the quotients of the insides. And finally, third rule, power rule, says that if you have a number, it could be a variable as well, in front of your log, that log can be put up as an exponent as such. Okay, so the m kind of goes up as an exponent is what we're saying. Please note with rules 1 and 2 that you have to have the same base. If you do not have the same base, then those rules don't apply. Okay, so for our question, how should we go about expanding this as a sum or difference of logs using these rules? These rules go back here. I apologize about that. You can go backwards. You can go left to right or right to left here, okay? And when you're trying to rewrite a one logarithm as a sum of logs, you typically use the rules in the other way, going from right to left here. All right, so let's go ahead and look at our expression that we're given. And what's the first thing maybe that we could try out of all these rules? Now, I see that we have an exponent on 5, so we can go ahead and use the power rule and put that 5 kind of down in front, and that's what this step over here does. It puts the 5 down in front. And where do we go from there? So some people say, well, it looks like you've got a product between the x squared minus 1 and y to the fourth, which is correct. And you also have a quotient. We're dividing by 8z cubed. And overall, I see this as a quotient. The main structure of this is a quotient. So that's why I'm going to go ahead and use the quotient rule, which says if you take the log of the numerator minus the log of the denominator, okay? So, and the reason I don't say a product is because, there is a product, but only in the numerator, and actually also in the denominator with the 8 and the z cubed. But the whole structure, though, it's a quotient, it's a division. So anyways, that's what we use the quotient rule, and this is how we get to this step. All right, so what can we do next? And also note that the 5 is outside. We are only operating on this part over here. All right, so what can I do next? Well, if you look at what we have with the x squared minus 1 and the y to the fourth, there's a product. And therefore, I can go ahead and use the product rule there. And this now becomes log base 7 of x squared minus 1 plus log base 7 of y to the fourth. And likewise, I see the same thing with log base 7 of 8z cubed. That can break down as log base 7 of 8 plus log base 7 of z cubed. Okay? And please note, I forgot it, there's a minus that should go outside of the parentheses of the log base 7 8 plus log base 7 z cubed there, because the operation itself of the product rule is just on the 8 and the z cubed. All right, so a couple things we could do from there. We can distribute this negative we have here and here, and that's how you get to this next step. And what can I do next? Well, there's a few things you could do. If you notice, with the x squared minus 1, that x squared minus 1 can factor as x minus 1 times x plus 1. So we get that. And that's about it. That's done in that step. But if you notice, there is a product here between the x minus 1 and the x plus 1. So we can use that product rule again and rewrite that as log base 7 of x minus 1 and log base 7 of x plus 1. So it's a little tricky, and we have to be careful, because you often will you do an operation, and you can do that operation again, in this case the product rule, but we tend to sometimes overlook that because we think, oh, we did it, that's it. But yeah, sometimes it can be done twice. Now, a couple other things that I did from going from this line, like this in red, right here, to this line. I also put the 4, that's right here, I put it in front. And the 3, that's on an exponent here, and I put that in front. So that's what you see here. So the 3 comes in front, and the 4 as well. And is there anything else that can be done? Not much. We can distribute the 5, which is what I did in this step right here. Everything gets a 5 in front of it, essentially. And you have our answer. Okay, and yeah, usually that's the case, that you have a number in front of a parentheses, like we do here. You distribute that number, and your final answer is with the number being distributed. All right, thank you so much. Hope this helps.